All right, thank you everyone for joining. We're going to go ahead and get started. So the presentation today is on the environmental economic cost of your fleet. And while there's many ways to do this, one such tool is using AFLEET, which is a free software program developed by Argonne National Labs. And that's the presentation for today. So joining us today is Andrew Burnham, who is from Argonne National Labs. He's the principal environmental scientist there. He is the individual who developed the AFLEET tool and most recently also updated the tool for 2016. So just as a kind reminder to get as much out of this webinar as possible, if you have not yet downloaded that AFLEET tool, you can do so in the next few minutes while we introduce you to what the West Coast Electric Fleet is. So the Pacific Coast Collaborative is this large overarching group made up of the governments of BC, Washington State, Oregon, and California. One of the mandates and targets that they set out was lowering the emissions from the transportation sector. And from this, the West Coast Electric Fleet program was announced and put forward in 2013. Since that time, the fleet has grown to 35 partner fleets, ranging from the BC to BC, so Baja California up to British Columbia. To join the fleet, all you have to do is just sign the pledge. There's 3 levels to the pledge: the on-ramp, the highway, and the express lane. There's no penalty if you do not meet your pledge targets. It's just meant to be an encouragement to get you to start thinking about electric fleets, and also to offer a toolkit, different resources that are available to you, cost calculators such as the one that we'll be discussing today, but also case studies and different funding incentives. So if you are featured as a West Coast Electric Fleet partner, we do develop a case study for you and put that up on the website to help kind of promote the different programs and incentives that you, as a certain jurisdiction, have put forward. And just recently announced Friday is an additional incentive. This one is for BC fleets only. It's the BC Fleet Champions program. And in addition to the resources on the West Coast Electric Fleet site, the BC fleets will also have access to free fleet business case assessments. This includes EV suitability assessments and EV telematics, as well as simple business case analyses. In addition to the business case assessment, fleets will also be eligible for charging incentives, charging station incentives. This includes free site assessments and 33% of total cost of the purchase and installation of charging stations, up to $2,000 per charging station head. So to join, again, visit the westcoastelectricfleets.com website and sign the pledge. If you have any questions, feel free to contact myself or any of the administrators on that website. So I'm going to turn it over to Andy, who's here today. All right, Andy.
Yes, can you hear me okay?
Yep.
Okay, so let me see if, just want to make sure that you can see my screen, and can you see the presentation?
Yes, thank you.
Okay, yeah, if there's any issues, please speak up, but so I'm very happy to be presenting. I've been kind of working towards getting this presentation for you guys for a while, and so I'm glad that we have this opportunity. So as mentioned, I am Andy Burnham. I have developed the AFLEET tool, and so we're going to talk about how that tool can help you examine electric vehicle costs and emissions. So first I'm going to give a little bit of background on the tool, why it was developed, who kind of sponsored it, And then after I give some information about the tool, I'll do 2 quick demos through presentation slides. If there's time, I can go into the spreadsheet. It's a spreadsheet-based tool. Otherwise, I can just answer questions. So Argonne is a U.S. Department of Energy National Laboratory, and it has been supporting the Clean Cities program within the Department of Energy with tools and technical analysis for more than 15 years. And so we've developed tools for the Clean Cities program, which primarily is U.S. based. That there is some connection with some Canadian locales near the border as well. And so some of the original tools, we were looking at a program that was 10, 15 years ago, looking more at air pollution, kind of the name Clean Cities, and so we developed a tool called AirCred, which allowed you to look at ozone precursor and carbon monoxide emission credits from alternative fuel vehicles. After that, we developed the Clean Cities AOI for emissions benefit tool, and this was based on the United States Recovery Act and trying to estimate the GHG air pollution benefits for proposals. And then we developed the GREET Fleet Footprint Calculator. So this was really a corollary to fueleconomy.gov, which provides information for light-duty vehicles, but really there isn't much or anything really for medium and heavy duties at that point. So this tool helped fleets look at petroleum use and greenhouse gas emissions. So the latest tool that we developed is called AFLEET. An AFLEET tool examines light-duty, medium-duty, and heavy-duty vehicles, and it looks at petroleum use, greenhouse gas emissions, air pollutant emissions, and also cost of ownership. So a lot of the tools we developed before were really on the environmental side. This time we really wanted to kind of be a little more holistic, look at both the environmental impacts as well as the economic impacts. So the tool contains 16 fuel and vehicle technologies currently. So on the conventional fuels, it's gasoline and diesel. We compare, our alternative fuels and other vehicles to those really baselines, gasoline for light duty and diesel for heavy duty. And then we have hybrids, both gasoline and diesel, as well as hydraulic hybrids. And then plug-in electrics, so ranging from kind of a PHEV to an extended range electric vehicle all the way to an all-electric vehicle. And then alternative fuels ranging from biofuels like ethanol and biodiesel to natural gas-based fuels like compressed natural gas or liquefied natural gas, propane as well, and then hydrogen for fuel cell vehicles. The tool includes 7 major vehicle types, which I think I'll talk a little bit later about, but we really have a lot of default information on the cost, fuel economy, VMT for 23 different vocations. And so the tough thing about fleets is that, no fleet's the same, and there's a really wide range of jobs that vehicles are doing. So on the light duty side, it still can be moving, people from here to there, but, ranging all the way to Class 8 long-haul trucks. So we have something, analysis for those 2 extremes and everywhere in between. The AFLEET tool 2016 version was released about 2 months ago. It's available on the GREET website. I'll talk a little bit about GREET in a moment. And you can see the user manual, and we also have some other webinars that I've given and more material to learn more about how using the tool. So what are some of the key data sources that we use to develop a tool that looks at these environmental and economic factors? So Argonne is known for the GREET model. It's a life cycle analysis tool. As you can see here, what the tool or that model does is estimate the environmental impacts of different advanced vehicle technologies and alternative fuels from a well-to-wheel basis. Kind of from left to right, you see well to pump. So an example for, let's say, petroleum or gasoline is that you're going to have emissions from drilling a well, producing oil from that well. You'll transport that oil to a refinery, so there's some shipping emissions there. And then you'll be at a refinery, so there's refinery emissions, and then after that you're refining after the refining, you send the gasoline to your pump. So we want to be able to look in a holistic life cycle perspective of all the emissions from that supply chain, basically, and then also, from the vehicle. That's where typically people think about the emissions, but we're expanding that, and that's especially important for alternative fuels and, of course, electric vehicles. There's no emissions from a tailpipe from an electric vehicle, but that electricity will come from somewhere else, and that may be from a fossil fuel plant that has significant emissions. So we need to be able to understand that whole life cycle so we can compare really the environmental impacts. So using the GREET model, we have petroleum use and greenhouse gas emissions, as well as fuel economy data. And then we also use the U.S. Environmental Protection Agency's MOVES model. So this is a vehicle simulation tool that provides air pollutant emissions. So we do this, again, this is US-based, so we have state-based emission factors for gasoline and diesel primarily. That's what that model covers. We use some of the research that we've done on comparing that to alternative fuels. Obviously for electric vehicles, there is really no vehicle operation emissions except for some tire and brake wear. And then we also use the Clean Cities Alternative Fuel Price Report. So as I mentioned, Clean Cities is a Department of Energy program, and through that effort they look at the fuel pricing on a state-by-state basis. And so, kind of see in this chart that fuel prices are going to be different depending where you are. And so we capture that and provide, at least on the default, whatever your kind of typical state-based price will be, but as the tool is a spreadsheet, allows you to kind of overwrite and put your own data as well. So what does AFLEET tool do, or like how does it calculate things? Well, it really depends on what your goals are. It has really 3 calculation methods. The first is a simple payback calculator, and so this is really looking at comparing the purchase of a new alternative fuel vehicle versus its conventional counterpart. And so, as I mentioned, conventional is gasoline for light duty and diesel for heavy duty. And so what we're trying to do is look at some of the incremental costs of the new AFV. So let's say for a electric vehicle, we see that those vehicles cost more than their gasoline counterpart, and there might be also some infrastructure like an EVSE. So that is an incremental cost that you have to kind of outlay at the initial purchase. But as we see with these vehicles, that they have much lower operating costs. So in a certain amount of miles driven or years of operation, you're able to likely pay off that kind of incremental initial cost. So that's kind of a good starting point to give you a sense, does this vehicle make sense for us? How long is it going to take for us to kind of break even at least? The next is a total cost of ownership calculator, and so this takes really the economics of kind of this new vehicle purchase to kind of a little more detailed level. We're looking at net present value of the cost of the vehicle over the years of planned ownership, and so we get into a little bit more detail and kind of really try to understand, the economics in a little bit more detail. So, kind of depending on your needs, you might say, I just want it something quick and dirty. I use a simple payback calculator. Total cost of ownership, I want to kind of tweak some more of the details and see what the lifetime ownership cost might be. And so for both of these calculators, it's not just cost, it's providing, for the simple payback calculator, it's providing annual environmental factors like petroleum use and greenhouse gas emissions, as well as air pollutant emissions. And then the total cost of ownership, it's lifetime, environmental emissions and petroleum use. And then the final tool is the fleet energy and emissions footprint calculator. And so this really is similar to the tools we had developed in the past, that many fleets were interested in understanding what are the emissions of my existing fleet. And so I might have lots of vehicles that are 10 years old. This tool uses data to kind of estimate deterioration rates for air pollutant emissions, so we can estimate kind of where the high emitting vehicles are, and so you kind of can take your information from a fleet inventory type software or however that's done in your fleet, and then plug it in, basically copy and paste into this calculator and get these environmental impacts. And so it kind of can help you at least identify maybe some of the key vehicles on the environmental side that, could be the targets for replacement, and then you can use that into kind of inform your use of the other calculators as well. So in this latest version, we've added some new features. So for alternative fuel vehicles, one of the interesting or things, maybe not necessarily for electricity, but for some of the other alternative fuels, is that if you develop your own station on site at a fleet depot, you often can get a much lower price than you would if you were relying on a public fueling station. So we provide now both public and private station pricing based on the Clean Cities reporting. And then you can also look at a range of prices. So obviously, fuel prices are impossible to predict, and so we can basically allow you to look at kind of a low, high, average, estimate and say, well, if gasoline is $3 a gallon versus $2.50 versus $3.50, what are kind of my economics looking like, at those ranges. And you can also look at ranging, fuel prices or electricity prices as well. Another thing is that we added refueling station and EFE infrastructure, construction costs, operation costs, and maintenance costs. Obviously for ESEs, it really depends on kind of the equipment you're putting there, and so it can go from something a consumer has and kind of the base level that would go in a garage to something either for workplace charging or public charging, all the way to DC fast charge. So we have some default information on kind of all those types of equipment. Well, again, as a spreadsheet, you're able to enter your own information, and we highly recommend, putting your own information in, because that makes the analysis more realistic to your specific case. But we do provide a lot of this default, vehicle cost, infrastructure costs, so you can at least get a starting point. The next kind of big update is that we are using the GREET model, and so we continually use the latest data from our life cycle analysis. I was involved in a report looking at heavy-duty fuel economy and emissions data last year, and so that was a major addition to the latest GREET model, where we kind of, for the most part, GREET has always been a light-duty focus model, and so we added heavy-duty. So that data was incorporated into AFLEET. We also included fuel cell vehicles. Obviously, fuel cell vehicles are becoming available. California, West Coast is the prime example of where they're being leased, and then stations are being developed. And then we also included some more updates on some of the other alternative fuels and pathways for hydrogen. And then the EPA updates their model as well, so we're including the latest air pollutant emission factors from that model as well. One of the other additions that we include is externality cost, and so some of the people that we worked with, the stakeholders from Clean Cities, were interested in trying to evaluate the different costs, or kind of like, how do you say what is more important, petroleum use, GHGs, certain air pollutant emissions, whether it's carbon monoxide, NOx, or PM. And so what we did is, looked at the latest literature on, what kind of the economic damages there are, or from, say, greenhouse gas emissions or air pollutant emissions, or what are some of the impacts of using petroleum use that aren't necessarily captured in, well, at least the market for that's included in your gasoline price. So we looked at the literature, and while this is highly dependent on a lot of assumptions, it gives you at least a ballpark sense, and we're hoping to improve this data as more information comes out. But this info is really county specific for the U.S., so we have specific county data, and so air pollution impacts will be greater in places like Los Angeles or San Francisco or Vancouver, where there's significant population density. In more rural areas, air pollutant emissions will be less impactful. So that kind of gets at least some of people thinking about like what matters, or how do you weigh these different factors. So now that I kind of ran through some of the tool and some of the new features, I want to kind of just go through what kind of information you would typically need to kind of do an analysis with AFLEET. So the first step often that fleet managers or people who are working with fleet managers is really just auditing or getting a sense of your existing fleet. And so we're doing this from a energy and emissions footprint approach. So we're saying, okay, let's look at the environmental impact of your different vehicles. So really the first step, as I mentioned, is looking at your location. So you enter your state, you can enter your county if you want to look at these externality factors. After that, you basically can enter some fuel production assumptions depending on which vehicles you have. So, in the case that you do have electric vehicles, if you can see near the bottom, I'm not sure if you can see my mouse, but that you can enter the grid mix for the plug-ins, the EVs as well, and if you're using fuel cell vehicles with electrolysis, you can enter that as well. But basically, we have some of the NERC regions, which are U.S. regions for kind of the large-scale grid. But then you could enter something more local, user-defined information as well. So that allows you to kind of put that in there. The next step is really, copying and pasting data into the spreadsheet. And so the information that you need is your model year, your annual mileage, and then your fuel use. And then after that, you use a drop-down menu to pick which kind of vehicle you have. And so in this case, looking at about 25 different passenger cars, they're all running on gasoline. They range from 2005 to 2007. And so the chart, after you paste in that information, you can scroll to the right and you can get the specific environmental factors for each individual vehicle. And then I'll show you on the next page, you'll be able to look at basically charts that summarize on a vehicle type basis, where the emissions are. So you'll see, in this example again, we chose only passenger cars, and it gives you that breakdown of the total, footprint of your vehicles. And then we again provide both tables, charts as well on different factors. So here you kind of see that externality factors. You see the dollar signs next to things that you typically don't see dollar signs next to: petroleum use, greenhouse gas emissions, and different air pollutant emissions. And so, if you had different types of vehicles, you could see, okay, yeah, here's where the most, emissions are, the most kind of, economic damage is estimated to be. So that's really it for doing a, footprint. It's really just, copying and pasting some of the data that you should already have. It's pretty straightforward. So the next step is, okay, I have a sense of, what vehicles are in my fleet, what the environmental factors are. What if I replace these vehicles? What if I, buy something new? And so you can use the simple payback and the total cost of ownership calculators to really look at that. So in the spreadsheet, again, you're probably, if you already had used the spreadsheet to do the previous step, you already have state and county, and then the next step is to enter the vehicle types. So here we're again looking at passenger cars, and then after you enter the passenger cars, you enter some of this, key info like the number of vehicles you're interested in comparing, the annual mileage, the fuel economy and purchase price is also there. And so by default, we have annual vehicle mileage, fuel economy, and purchase price already there. So as I mentioned previously, you can overwrite this to, better estimate, what it is for your specific application. So obviously, mileage will depend on the fleet. Fuel economy will depend on the vehicle that you're interested in, and as well as purchase price. But that's kind of like some of those key things that you first need to enter. And then if you're looking at heavy duties, it would be the same type of application. We do have heavy duty electric vehicles as well as fuel cell and some hybrids as well. The next step is entering the fuel prices. So you can choose again as either public or private station pricing. And then you can decide whether I want to look at some fuel price sensitivity. So all this information is based on kind of the typical fuel unit you'll see at the pump. But it really, what we do provide kind of next to this table is some breakdown to look at it on a kind of energy equivalent basis, because sometimes it's hard to say, oh, how do you compare a gallon of gasoline or a gallon of diesel or a kilowatt hour or something like that. So we do that on GGE basis next to that table. And then, so again, this is all state-based. So we don't have Canada, but we do, have the various states. And so if, depending on your state, here's the default price information. But again, you may want to adjust this for your specific application, and then, look at kind of do this as scenarios. Well, if the price is going to be kind of do some ranges and see how that really impacts your results. The next thing, if you wanted to do a total cost of ownership, there actually isn't a ton of inputs on the major input sheet. You just really look at how many years you're going to own the vehicles and the infrastructure. You do some loan terms, if you have a loan or you would plan to do a loan, and then you look at the discount factor. So this is trying to estimate really kind of the internal rate of return for a business or municipality. This is by default it's pretty low, but that's kind of more on a consumer side what a discount factor might be. But for a municipality it might be 5%. For a business it could be 12-15%, depending on what they're looking at. And then finally, again, you would look at your fuel production assumptions for the vehicles or fuels that you're interested in. So here in this example, you can kind of see for the source of electricity near the bottom that we're looking, at a region 11, so that's WEC, so the West Coast. But you can adjust depending what grid mix that maybe you have. Maybe there's something connected to renewable power or something like that. You can enter that data. So if you're looking at plug-ins or extended range vehicles, there's a couple of other inputs that are going to be helpful or better to enter. And so the information on the first sheet on fuel economy was basically everything was charge sustaining or kind of your hybrid mode. So we have also kind of your EV mode fuel consumption, how much electricity are you using per mile. You can enter that there. Again, we have the defaults. One's kind of based on a plug. I guess now somewhat gone, the plug-in Prius that was previously there for the PHEV, and then or no, actually, yeah, I'm pretty sure the plug-in Prius. No, it might be. Oh, sorry. I think that's actually the Ford Energy. I'm sorry, C-Max Energy. And then the EREV is based on the number for the volt. So you can enter that data, there, or you could adjust, look at how many times you charge per day, and then how many days you drive per week, and that will adjust how many miles you actually drive on, kind of the EV mode versus how you drive on the kind of gasoline mode. And then there's other assumptions as well, like maintenance and repair costs and things like that. So you could enter some of that as well here. And the next, if you're going to do that fuel price sensitivity, we have some already kind of ranges already built in, but you can adjust, both doing a low and high case for both, the conventional fuels or even some of the alternative fuels as well. You don't have to re-enter, if you're looking at gasoline and you're also looking at gasoline hybrids and plug-ins, you don't have to re-enter kind of that range. Once you chose it for gasoline, it'll go for basically all the other vehicles that use that fuel. And then basically finally for the input side is that if you're looking at infrastructure cost, you can enter that here. And so in this case, we're going to look at EVSEs, and we're going to do basically maybe dual pedestals. So for the 25 vehicles that we're doing, so we'll have maybe one extra basically here, and we'll do 13 EVSEs level 2. We provide data on both the the initial purchase price and then also some operation and maintenance costs as well. And you can again adjust that if you have better data. And then after that, you're basically ready to look at the results. And so one thing to mention, here are kind of the economic paybacks. So we don't necessarily, in our kind of default cost information, we don't include incentives or tax breaks or things like that. So that oftentimes is, there's regional or local and sometimes federal, obviously federal incentives for electric vehicles in the U.S. And I believe in some of the provinces like BC has, their own incentives. So you would need, that kind of secondary page, you can either enter the incentive there or just kind of adjust your vehicle price. But this basically will give you some. After you do that, you'll get the estimates of paybacks. And right now, with kind of the default cost that we have today, with low fuel prices, the economics of switching over, you're not going to get extremely fast paybacks, but depends on how many miles you drive. That case, I think we're looking at 11,000 miles per year, and so if you're driving more, you can take advantage as long as you have enough range and you can meet that duty cycle. You can have faster paybacks for some of these PEVs. And then also you're going to see petroleum use, greenhouse gas graphs and tables to give you kind of the results. For the air pollutant emissions side, one thing to note is that for electric vehicles, we're really only focusing on tailpipes. So the next one is air pollutant emissions. So that's something to be considerate of. If you're really wanting to examine air pollution impacts of electric vehicles, I would recommend the GREET model. We're thinking about how to incorporate that into the next AFLEET, but that's just one of the issues of, of trying to do a kind of an analysis, because especially when you're looking at externality cost, you really need to know where the power generating unit, where the power plant is, and so that becomes a little tricky doing this type of analysis. And then when you look at the total cost of ownership, so we're looking at something like you'll have some type of cash flow analysis. So starting year one, you purchase the vehicle, and then as you have potentially some fuel savings or operation and basically repair and maintenance savings from different vehicles, you'll see kind of a crossover point that's similar to kind of your payback. And then you'll see as you go over that time frame, you'll see whether you kind of have a positive cash flow or negative cash flow compared to our default. So in this again is we're comparing to gasoline. So in a lot of these cases where you're maybe down a little bit, it's it depends, and you can see kind of how the different fuels rank. And I think in one case the gasoline hybrid basically crosses over in year 6 or so. And then we also have these total cost of ownership type graphs that will include the various pieces of your ownership, so ranging from kind of financing costs to depreciation, your fuel, if it's diesel, you'll have diesel exhaust fluid, maintenance and repair, insurance, license and registration as well. And then again, more on the environmental side, again, more charts on petroleum use, GHGs, air pollutant emissions. So in summary, the AFLEET tool really can help you look at the economic and environmental costs and benefits of AFVs. It helps you to inform you on new vehicle purchases, and it can help you examine the energy and emissions footprints of existing vehicles. Default data is provided for really all the key inputs, but using your own makes the analysis more meaningful and more representative of your specific case. And then AFLEET 2016 included several new features, including public and private fuel prices by state, infrastructure costs, hydrogen fuel cell vehicles, and then as well as externalities and other costs of petroleum use and emissions. So I want to thank my sponsors at the U.S. Department of Energy and a lot of my colleagues at Argonne for helping with the development of this tool. And if you have any more questions, you can here to answer them, or you can shoot me an email as well. Thank you.
Thank you, Andy, for the presentation. That was fantastic, especially some of the updates to the AFLEET tool, such as the accounting for the charging stations cost now. That's great. So we do have a few questions, and hopefully we have enough time to get through them all. First question from a member was, how well does the AFLEET model account for battery manufacturing costs and emissions?
So that's one factor that, I think I showed in one of the charts, basically something, that total life cycle. And so right now, I can maybe scroll. Can you still see my slides?
Yes.
Okay. So in this, in this chart or this representation, there's the fuel cycle and the vehicle cycle. The fuel cycle is the steps to produce the fuel from its raw state to getting it into the vehicle. And then you can kind of see on the top down is the vehicle cycle, and that is producing the materials that go into the vehicle, whether it's steel or aluminum for some of the body parts, or chassis parts, or battery materials for a lead acid battery all the way to a lithium ion battery for an EV. So we do have that analysis in GREET. So we do allow you to look at some of those factors in the GREET model. In the current version of AFLEET, we do not have the vehicle cycle. That is something we could we're considering adding. That's been brought up before. In general, the battery emissions on the GREET analyses are relatively small. It's not a huge factor, even for larger EVs. I just gave a webinar a few days ago, and we were talking about some of these issues. But yeah, that's a great question. And if you want to look at that, GREET is the place to go.
Thanks. The next question is, has the AFLEET tool been updated to now include renewable diesel in its calculations?
That's a great question. Again, we're always a little bit behind what we have in GREET, depending on the fuels. This is kind of a clean cities type decision, whether they wanted to get into renewable diesel and include it in AFLEET. Again, it is in the GREET model, and we have those pathways, so it's relatively straightforward to port over to AFLEET, but at this point it's not in there. And I know in the West Coast, obviously, that's becoming an important, or a fuel that's has a lot of attention. So that definitely is something we'll continue to push with our sponsors to add to the tool in the future.
All right. A next question appears to be more of a clarification than anything. Was the left axis, payback in years, on the simple payback table meant to be in months? Otherwise, it appears that the payback would be 50 to 250 years.
Yeah. So again, as I mentioned before, that the case with very low gasoline prices, and that was just the specific case that I'm running there. You have to look at electricity prices, which are potentially going to be different than, we're using average electricity prices, and you might be able to get something different than that. So it really depends. But, in those cases, without an incentive, again, remember it's without a, for the U.S. $7,500 U.S. tax credit, or I think for BC, it's something like 5,000 Canadian dollars or something like that. That will definitely change the economics. So in my case, I ran it without, incentives, but, with incentives, that definitely will change it. But it is years, so you can see, very long paybacks, if the incremental cost is very high, especially I think for, I don't know if that was a fuel cell vehicle or not. My phone there, my computer's was frozen there, but yeah, so that's a good question though.
And a follow-up question, after installing over 1,000 charge points over the last 4 years to support our fleet and employees, our average price per plug is at $13,000. What drives this price up? Our on-site costs, I have historically found. Do you have any comments for that?
Absolutely. So I think that's one of the difficult pieces of cost in general is, well, there's lots of different issues with cost, but I mean, one thing's changed by time, so especially like fuel and even vehicle price costs, those will change. On the infrastructure side, it's really heavily dependent on specific specifications of, whatever you're installing. And so that can impact, based on the location you are, just the state and labor costs in your area. That can be really go down to the specifications of whatever you're installing. And so for EVs, we here at Argonne, we've been deploying lots of EVSEs here and doing different testing and stuff like that. And yeah, it depends if you're going to have to break a lot of concrete to, run, electricity to a parking lot, depending on how far that distance is. And so it really does depend. And I think, we have some ranges of that data within AFLEET and kind of in the background. I'm not sure how fast I could show you in quickly. You want to see me scroll through a spreadsheet, but basically a lot of like the inputs for here for the infrastructure costs, it really it will depend. And so I think for that gentleman, he could put in that data, but there's other programs to kind of talk about, I think, how to reduce some of those costs. There are best practices to try and reduce, but sometimes you're kind of stuck with the location you are, and you have to kind of deal with that. But yeah, hopefully that kind of answers that. But yeah, if you're interested in getting some more of the details of the typical or average cost, you can click on, if you see the sheet I'm showing right now, it says infrastructure inputs in blue. There's a lot of sometimes little red marks where it will give you more information, or you can click that, basically a hyperlink, and it'll show you some more information about our default assumptions.
Thanks, Andy. The next question refers to a comment you made regarding 11,000 miles for payback period. Does this mean EVs only make sense if you drive more than 11,000 miles?
No, I don't think that's specifically. So one of the issues, the way this tool handles it, and I can quickly scroll back, is like, I was running some example basically of some fleet data and saying, well, on average, these 25 vehicles drive 11,000 miles per year. And then using, basically the costs that are already defaulted. I didn't change anything here to, run something. But let's look at the price spread. We're seeing, roughly, about $10,000 for the EV case, which, I think is basically along the lines of a Leaf-ish type price, I believe. And so that $10,000 is an added cost. And then all the EVSEs that we have, included here, that's an added cost. And so in this specific case where fuel prices, we're talking gasoline, the private station price that is being used is $2.84. Electricity price is definitely on the high side, being California. It's 16 cents per kilowatt hour. It just really depends on your assumptions, and I think that's you know, the interesting part is to get a sense of like, you know, does it make sense in my application? And if you only drive 5,000 miles or something like that, you don't use the vehicles that much, purchasing a very expensive piece of equipment, you know, you really need to have huge amounts of savings on the kind of fuel use side to make up for it. So it really will depend on your specific application, and you know, we'll give you kind of at least some of the tools to help, you know, see if it makes sense.
And one last question is, how long do the charging stations typically last for?
Yeah, that's a very good question. I think for the most part, you know, the data that we have right now is, I want to say, I think some of the assumptions are, again, a lot of these things were put out, some of them were put out, you know, late, you know, 2010-ish area or something like that, or even the ones put before that, you know, aren't really at that point of, you know, obsolescence at this point, so they're still operating. So there's its question is TBD. I think we've seen some assumptions, you know, that you know, some of this equipment, maybe the lifetime's 15 years, but I don't think there's a great, I don't think I'm the person to answer that exactly. I don't think we have exactly the cost or the lifetime data for those things. You know, we do include some kind of annual operation and maintenance cost, depending on what it, you know, what the specific type of equipment it is. You know, this is depending on whether it's a natural gas station or EVSE. And we have some assumptions on those things too, and you know, these things can depreciate over different times. So that's a good question, a tough one, probably one I just don't have the answer to.
And one last question now. How important is driver behavior for reducing emissions?
So, you know, it depends on the vehicle type. And absolutely, I think for electric vehicles, we've done some studies on really the fuel economy for different vehicles depending on duty cycle. And so you'll see in cases specifically like for gasoline, if you're driving on the highway and you're driving at relatively steady speeds, you get a boost of fuel economy. You know, a highway mileage is better for a gasoline vehicle. For the EV, you know, you kind of, the difference between how you drive it, whether it's on the city or the highway, it typically, you know, isn't as big of a change, you know, depending on the specific vehicle. But I think, you know, on gasoline vehicle, air pollution, you know, hard accelerations really are a huge part of, you know, where some of the particulate matter emissions. So that's kind of a complicated thing, you know. It depends on different factors what you're specifically looking at. But in general, you know, driving at steadier speeds, less stop and go type driving. For EVs, even, you know, your use of a heater is going to impact kind of your electricity consumption. So, you know, it can depend depending on the vehicle, but yeah, that's a good question.
Great. Well, thank you, Andy. Want to say if anyone has any additional questions for our presenter, you can email myself or Andy, and we'll try to get your questions answered for you. The webinar today has been recorded, and it will be put up on the West Coast Electric Fleet website. So feel free to access that in the next few days. And thanks again.